In this video tutorial is the ultimate guide to building your own generative AI model from the beginning. Understand the importance of AI, follow step-by-step instructions, and discover endless creative and innovative possibilities. Generative AI models are designed to generate new content by learning patterns and structures from existing data. These models often utilize neural networks, which are inspired by the human brain, to create unique outputs based on the input they receive. Training a generative AI model involves exposing it to a vast amount of data, allowing it to learn and generate novel content. Step 1. Define your objective. Before diving into the training process, it's crucial to define the objective of your generative AI model. Are you looking to generate realistic images, create human-like text, or compose music? Clearly outlining your goal will help you choose the appropriate architecture and dataset for training. Step 2. Choose a framework and architecture. Selecting the right framework and architecture is fundamental to the success of your generative AI model. Popular frameworks like TensorFlow and PyTorch offer a variety of pre-built architectures that cater to different tasks. For image generation, architectures like Generative Adversarial Networks, GANs, or Variational Autoencoders, VAEs, are commonly used. Natural language processing tasks may benefit from recurrent neural networks, RNNs, or transformer architectures like OpenAI's GPT, Generative Pre-trained Transformer. If you like such stuff, subscribe to my YouTube channel ITFO. Step 3. Collect and pre-process data. Data is the fuel that powers generative AI models. Gather a diverse and representative dataset relevant to your objective. For image generation, this could be a collection of high-resolution images, while text generation may require a large corpus of text data. Pre-process the data to ensure it is in a suitable format for training, and normalize it to enhance the model's learning process. Step 4. Build and configure the model. With your data ready, it's time to build and configure the generative AI model. Define the architecture, set hyperparameters, and initialize the model. Depending on the complexity of your task, you might need a deeper network or additional layers. Adjust parameters iteratively, keeping an eye on the model's performance during training. Step 5. Train the model. The training process involves feeding the model with your pre-processed data and allowing it to learn the patterns within. This typically involves numerous iterations, adjusting weights and biases to minimize the difference between the model's predictions and the actual data. Be prepared for this process to take time, especially with larger datasets and more complex tasks. Step 6. Fine-tuning and optimization. Once the initial training is complete, fine-tune your model to enhance its performance. Experiment with different hyperparameters, adjust the learning rate, and consider regularization techniques to prevent overfitting. Continuous optimization is key to achieving the desired level of creativity and accuracy in the generated content. Step 7. Evaluate and validate. Evaluate your generative AI model by testing it on a separate validation dataset. Assess its performance metrics and adjust as necessary. This step helps identify any potential issues, such as overfitting or underfitting, and allows you to make informed decisions on further improvements. Step 8. Generate and refine output. After successfully training and validating your model, it's time to unleash its creativity. Generate new content and refine the output based on your preferences. This step often involves a feedback loop, where you iteratively adjust the model's parameters and fine-tune it based on the generated results. Step 9. Scale and deploy. Depending on your application, you may need to scale your generative AI model for larger datasets or deploy it in a real-world setting. This involves considerations for computational resources, model serving, and integration with other systems. Choose an appropriate deployment strategy to ensure your model can handle the demands of its intended use.